Assalamu alaikum dear viewers, Shoaib and Dayo is here with another lecture of the electrical machines, and today we are going to discuss the DC series generator. So it is another type of the self-excited DC generator. So recall the concept of the self-excited DC generator is that self-excited DC generator can be defined as whose field magnet winding is supplied the current from the output of the generator itself is called as the self-excited DC generator. And there are the three types of the self-excited DC generator. Number first is the DC shunt mode generator, second is the DC series generator, and third is the compound mode generator. Okay, now we are going to discuss here the DC series generator. Now the series generator is that whose field winding is connected in series with the armature winding. So what is the purpose of the field winding in the DC machine? It is used for the production of the magnetic flux and the field in which the armature is rotated. So armature winding is the rotating part of the DC machine in which the working EMF is produced. In the case of the generator, the generated EMF is produced, and in the case of the motor, the counter EMF or the back EMF is produced. So let's discuss the DC series generator. So before going to discuss some points of the DC series generator, first we need to draw the circuit diagram of the DC series generator. Now there are the two windings, the field winding and the armature winding. So this is the armature of the series generator. Here these are the carbon bushes, and the field winding here is the fewer number of the thick wire. So the whole current of the field winding is carries by the DC series generator and towards the load, and this is the load. This is the armature in which the EMF is produced, because this is the generated EMF, and the current which is produced in the armature is called the armature current, and this is the shunt field series field winding. So this is the field winding, okay, and this RSE shows the resistance of the series field winding, and here the RA is the armature resistance, and this is the load, and here from the load we can get the terminal voltage. Okay, so first of all we need to write some few points regarding the DC series generator. So in the DC series generator, the armature winding or the field winding is connected in series with the armature winding, so that the field winding carries the whole current through the field winding and also the load. And so here also this is the IL load current and also ISE. So here number first point is that in a DC series generator, the field winding is connected in series with the armature winding. So from here, from this diagram, this is the armature winding and this is the field winding. so that whole current flows through field winding and as well as the load. So the armature winding is connected in series with the field winding, so that the whole load, whole current of the machine, of the series wound machine, is flow through the series field winding and as well as the load. Now the second point is that the series field winding is designed in such a way that it has the fewer number of the turns of a thick wire having the low resistance, say suppose 0.5 ohm. So second point is that the field winding has fewer number of thick wire having low resistance, say suppose 0.5 ohm. So according to the law of resistance, resistance is directly proportional to the length and inversely proportional to the cross sectional area of conductor. If conductor is thicker, then its cross sectional area is greater, then resistance will be low. Here the same thing, the field winding is designed in such a way that it has the fewer number of a thick wire, its cross sectional area is greater. If its cross sectional area is greater, then its resistance will be low. So obviously it can carry the more amount of the current. So this is the series wound generator. Now these DC series generators are used as boosters. So to boost the voltage or to regulate the voltage. So this was the few points regarding this circuit diagram. Now here we are going to discuss some formulae related to the DC series wound generator. Number first is that the armature current. The armature current, which is denoted as IA in here in the DC series wound generator, is IA is equal to the ISE is equal to IL, because here the armature winding is connected in series with the field winding and as well as the load. So the whole load current of the machine is the same one, the IA is equal to the ISE is equal to IL. Second is the terminal voltage, which is the V is equal to EG minus IA. Here we are going to consider over here the resistance of the armature IA, RA plus RSE, and also the resistance of the series field winding. Third is that the power developed in armature, which is the EGIA, and also power delivered to the load is EGIA minus I square RA plus RSE. So taking IA as a common, EG minus IA RA plus RSE. So here from the above formula, terminal voltage, so here EGIA and into RA plus RSE is the terminal voltage. So IA with the multiplied with this V. So IA is already equal to the IL. So VIL. So this is the power delivered to the load. So these are some essential formulas related to the DC series wound generator. So this was the whole lecture regarding the DC series wound generator, in which the field winding is connected in series with the armature winding, so that the whole current flows through the field winding and as well as the load. And series field winding is designed on the basis of the fewer number of the turns of the thicker wire having the low resistance. And also we have discussed some formulas related to the DC series wound generator. And this was the lecture, and I hope that you have enjoyed the today's lecture, and this lecture is informative for you all. I hope that, and at the last, do subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical machines and electrical engineering area. Thank you.